Hello class, today we're going to be going over Module 14 homework, and Module 14 is on piecewise functions. And piecewise functions are essentially just functions that behave differently depending where you are in the domain. So as we go through our x values, the nature of the function changes. So we're going to have different rules or different functions for different domains. So let's get into number one. An Airbnb host charges $125 a night for the first 3 nights you stay at their location. The charge then drops to $110 a night for each additional night up to 7 nights. After that, the rate drops to $95 a night. The host does not allow anyone to stay longer than 3 weeks. There is also a one-time service fee of $50. Define a piecewise function A to represent the cost of the stay for n nights in this Airbnb. So, it looks like we're going to have 3 functions here. We have our A of n, or 3 rules here for our function. So the first function, we have a $50 one-time fee plus $125 a night, and that's for the first 3 nights. So that's if n is greater than or equal to 1 or less than or equal to 3. Our next one, the next rate drops to $110 a night, but what we need is we need the total after 3 nights first. So after 3 nights, the total, this would be 125 times 3, which is $375 plus the $50. That's going to be a $425 after the 3 nights. But what happens after those 3 nights for the next 4 nights? 4 nights. So, sorry, I had to count there. So it's $110 a night, but it's going to be an n minus 3 here. And the reason we have the n minus 3 is you can check. Is if you were to plug in, let me just finish this first. If n is less than or greater than or equal to 4, or less than or equal to 7. So if we were to plug in, say, 4, right, and for n, we're only really being charged for 1 night at $110. So that's why we need the n minus 3 here. Plug in 4. This counts for the first 3 nights, and then this is the nights afterwards. So for our next rule in our function, it's going to be the same idea. We're going to have the total, and the total after 7 nights would come out to $865. That's really if I just plug in 7 in here for n. That's after the 7 nights. So 7 minus 3 is 4 times 110 is 440 plus the 425 is 865, and then plus, so we have the after the 7 nights, but after that the rate drops to $95 a night, and it's going to be n minus 7 in this case because it's up to 7. So there's going to be if n is greater than or equal to n or less than or equal to 21. 21, the reason why we have that is because the host does not allow them to stay longer than 3 weeks. So that is number 1. Let's go on number 2. Federal income tax rates depend on the amount of taxable income received. The following tax rate schedule shows the tax rates for unmarried single filers for 2018. So we need to write a piecewise function for this income tax. And this is going to be, let's see, write a piecewise function for income tax T as a function of taxable income I for single filers. So here we have our table. It shows that any income over $0 is taxed at 9%, and then, 10%. I don't know where I got 9. And then after $5,025, the tax rate goes to 12%. And that is only 12% after the 525. So say if you made 10,000 here, the first 9,525 would be taxed at 10%, but then the rest, the balance, the 475 would be taxed at 12%. So we need to write a piecewise function that models this. So we have t of I is equal to, and we're going to have a lot of rules here. I think we're going to have 2, 3, 4, 5, 6, 7 rules. So I'm going to make my bracket fairly large. So our first one is, let's see, it's going to be 0.10, so that's the 10% I, and this is going to be if I is greater than or equal to 0, but less than or equal to 9525. Next, we're going to have our 12% bracket. So we have 12% I, and this is going to be I minus 9525, just like our concept up here for number 1, because only anything after 9525 is getting taxed at the I, or at the 12%. So, and then we need the total amount that's already taxed before the 9525. So that's going to be simply the 9525 times 0.10, which is 952.5. And this is going to be if I is greater than 9525, or greater, or sorry, not greater than, equal to, just, I said greater than, just greater than, or less than or equal to 38,700. Our next tax bracket is at 22%. So it's going to be 22 times I minus, let's see, it's going to be 38,700. I just want to make sure I keep my numbers all straight here. There's a lot of things going on. Plus the total of the last one. So if we were to plug in 3,800 or 38,700 in for I, we would get a total of 4453.5. So this is the total tax amount up to 3,800. This is the extra tax after the 38,700. So this is if I is greater than 38,700, or less than or equal, and less than or equal to 82,500. Our next tax bracket is at 24%. So we're going to have I minus, let's see, I minus 82,500. Again, this is just the tax that we take out after the 82,500. And then plus the total of the one before at 82,500. So if I plug in 82,500 in for I and simplify, I should get 32,089.5. All right. And so that is if, that's if, oh wait, what am I doing here? Did I goof? Yes, this should, sorry, I goofed here. I was wondering why that was so large. This would be 14,089.5 after plugging everything in. So that is if, that's if I is greater than 82,500, but less than or equal to 157,500. Awesome. Our next tax bracket is at 32%. So we're going to have 0.32 I minus this time the 157,500, and plus the total of the one before. So if I were to plug in 15,750 in for I right here and simplify, I already get this 32,089.5 that I was talking about earlier. And that's if I is greater than 157,500, but less than or equal to 200,000. Our next tax bracket is at 35%. So we have 35 and this 5, and this is going to be I minus now 200,000, because this is representing only the amount after 200,000 is taxed at 35%. And then plus the total of everything up until that point, which in this case would be $45,689.50. I guess I could do zeros here, so I'm talking about money. And that's if, I just don't want to make it too clunky, if I is greater than 200,000, but less than or equal to 500,000. And then finally we have one last tax bracket, that is at 37%, anything over 500,000. So this is going to be 0.37, I minus 500,000. And then plus the total of everything before of all the taxable income up to 500,000, which the total would be $689.50. And that's if I is greater than 500,000. All right. So part B, use the function to calculate the tax for the following taxable income levels. Well, here what we need to do is we think, okay, 35,000. Let's see here. 35,000 falls into the 12% tax bracket. So what we're going to do here is plug in 35,000 in for I here, and after we do so, we get $4,009.50. This next one, 112,500. That's going to be in the 24% bracket, you see. So we would plug it in for here. We'd plug 112,500 in for there, and we'd get $21,289.50. And then finally, $1.5 million here. That's of course in the highest tax bracket. So we plug in $1.5 million in for I on this last rule here, and we would get a total taxable income, or I'm sorry, total tax as $520,689.50, just like that. All right. C. If someone owes $34,265.50 in taxes, determine their taxable income. Well, let's see. If someone paid $34,265 in taxes, let's see where that would fall. And that would actually fall in this 32% category, because this is the base level of the tax of how much taxes paid. So it would be 34 is just a little greater than that. So what we're going to do is we're going to set this rule equal to 34,265.50 and solve for I. And of course, we would subtract $32,89.50, which will give us 2176 equals 0.32 I minus 157,500. And then we would divide both sides by 0.32 here, which is going to give us 6,800. Is equal to I minus 157,500, and then add that amount to both sides. Add the amount, this amount here, and we're going to get I is equal to $164,300. So that's how much someone made if they owed that much in taxes. So let's move on. Number 3, a 2.4-mile swim, 112-mile bike ride, and 26.2-mile run make up an Ironman triathlon competition. A certain triathlete averages a swimming speed of 2.4 miles per hour, a cycling speed of 18 miles per hour, and a running speed of 10 miles per hour. Assume there are no transitioning time from one segment of the race to another. So, A, Develop a piecewise function for the speed s of the participant as a function of his time t in minutes. So let's just create a little chart here. We have the distance in miles. We have the miles per hour. We have the time to complete each one. And we have time in minutes because we want it in minutes. That's what it's asked of us to do. So we are swimming, we are biking, and we are running. So the distance of the swim was 2.4 miles, and the miles per hour was 2.4. The distance of the bike was 112 miles, and the speed was 18 miles per hour. And then the run, the distance was a marathon, 26.2 at 10 miles per hour. So let's see. To find the time it took to complete, what we're going to do is we're going to take the distance in miles and divide it by the miles per hour. 2.4 divided by 2.4 is just 1 hour. 112 divided by 18 is going to give us 6.22 hours. And then 26.2 divided by 10 is going to give us 2.62 hours. And then we just need to convert this to minutes, so just multiply it by 60. We're going to get, well, this is just 60 minutes. This is going to be 373.2. This is going to be 157.2 after multiplying the hours by 60. So now we have the information we needed, or we need to create our model. So S of t. Let's see. So the speed was 2.4 miles per hour for the first hour. So that's if t is greater than or equal to 0 or less than or equal to 60. Then the speed was 18 miles per hour, and that is if t is greater than 60 but less than or equal to 373.2 plus 60, which is 433.2. And then the last portion, it was 10 miles an hour, and that's if we start from 433.2 and t is less than or equal to the total time here, 60 plus 373.2 plus 157.2. That's going to be 590.4. And then B, sketch a graph of the piecewise function. So, let's see, we have 2, 4, 6, 8, 10. And then let's see here. 5, 10, 15, and 20. So for the first hour, it was at 2.4, so it's a little less than half of 5. And then after that, went up to 18 miles per hour. And he did that for another 6.2 hours, so that'd be at 7.22 here. 7.22. And then after that, it went down to 10 miles an hour. And went out to 984. So 7.22 is 9.84. These are just the x values here. Awesome. And then C, describe how each piece of the function models the 3 seconds of the race. Well, they swam 1 hour at a speed of 2.4 miles per hour. Then biked for 6.22 hours at 18 miles per hour. Yep. Then ran for 26.2 miles, or sorry, for 2.62 hours at 10 miles per hour. Just like that. All right, let's move on to the next page. Okay, so now number 4, a local copy center has the following pricing structure. Create a piecewise function that can be used to calculate the total cost of making n copies. So here we have C, the number of copies, and it looks like we have 4 rules here. So here it's going to be 0.15 n, n stands for the number of copies, if n is greater than or equal to 0, but less than or equal to 25. The price then goes down to 10 cents per copy if n is greater than or equal to 26 now, but less than or equal to 100, because that's up to 100. And then it drops down to 7 cents from 101 to 500. And then it drops down to 5 cents for over 500. Awesome. So B, use the function to calculate the cost of making 95 copies. Well, we would have to figure out which rule to use. 95 would be this one at 10 cents. So C of 95 equal to 0.10 times 95 equals 950. Then C, use the function to calculate the cost of making 505 copies. Well, that would obviously be this last rule here. That would be over 501, or 501 or over. So C of 505 is equal to 0.05 times 505, which is going to give us $25.25. And then D, how many copies could we make if we want to spend at most $24.50? So this is what we're going to do. We're going to try every rule and see what happens to the domain here. So we're going to set each rule here equal to 24.50, and you'll see what I mean. So if we have $24 or 24.5, and that's equal to 0.15 n, well, n, if we solve for n, would be 163.3 copies. Well, that obviously doesn't fall in the domain of our first rule. So this does not work, not in domain. Let's try the next one. So I'm going to set 24.5 equal to 0.1 or 0.10 n, and then n would be equal to 245. Well, 245 is not in the domain of the 10 cents, so that doesn't make sense either. So not in domain. The next 24.5, and then n, if we solve for it, is equal to 350. And again, 350 is not in the domain of the 0.0 of the 7 cent section. Oh no, it is. Yeah, this one is. 7 cents, the n falls in between 101 and 500, so this is in the domain. And let's just check the last one just for fun. 24.5 equals 0.05 n. Well, n would be 490. That's not in the domain. So how many copies could we make if we want to spend $24.50? 350 copies. Okay. So, part E, how many copies could we make if we want to spend at most $30? So, let's kind of do the same thing here. So, let's see. We're going to set 30 equal to 0.15 n. We're going to divide both sides by, well, 0.15, and we get n is equal to 200. So n, 200 is not in the domain of the 15 in, or of our 15 in rule, so not in domain. We'll do 30 to the 10 cents per copy. And and that's n. We get n is equal to 300. This again is not in the domain. And then we'll do 30 cents to the 0.7 because we've got to test all of these. And we get n is equal to 428.57, and that is in the domain of its section, right? The 7 cents, the 428 falls between 101 and 500. So let's just do the last one. So 30 equals 0.05 n, and if we're to solve for n here, we get 600, which is also in the domain of its own rule. Because 600 is greater than 501, so we can either get 428 copies. I just rounded down, right? We don't want to round up, or 600 copies. Awesome. All right, let's go on to the last page here. And 5 says, write the formula to define the piecewise function given in each graph. Let's see here. Remember what we need in order to create a function. We need its slope and we need a reference point, right? If you recall, we can create a function by m x minus x1 plus y1, or y sub 1, where x sub 1, y sub 1 is our reference point, and m is our slope. So I'm just going to create a reference point for all of these here. This first one, the reference point, will be at -7, -2. This second one, I'll have my reference point right here for this section, and that's going to be at -3, -6. And then my reference point for this last section, that's going to be at 3, -4. So to create my piecewise function, let's see. I'm going to call this one f of x. Let's see. So for our first section, it looks like the slope is -1. So -1 times x and then minus x1. So this is our point that we're using for this one. So it would be x plus 7 minus 2. So that's the function for this little section if x is greater than or equal to 7, or -7, but less than or equal to -3. The next one, let's see, it has a slope of 1/3, so it's going to be 1/3 x, and this is our reference point for this one I'm going to use, so x plus 3 minus 6, and that's if it's in between -3 and +3. And then our last one, this has a slope of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, and this is a reference point for it, so x minus 3 minus 4. And that's if x is greater than or equal to 3, but less than 4. And notice I didn't do less than or equal to because this is an open circle, which means that the value isn't or equal to there. Okay, now let's do this one. So again, I'm going to find my reference points. This first one is going to be at -6, 2. This one's at -2, -2. And then my reference point for this last line here, we're going to call it 3, -2. All right, so we're going to have f of x. Well, I'm going to call it f of x, I guess. So the slope for this first line is -1, and my reference point is -6, 2, so it's going to be x plus 6 plus 2, and that's if x is between 6 and -6 and -2, right? Because that's just this section right here between my fingers. And then this next section here, well, it doesn't have a slope, so it's just going to be -2, right? It exists as -2 the whole way. And that's if x is between -2 and 3. And then finally, this will go up. This one has a slope of, it looks like it's 3. So this is going to be 3x, and this is my reference point. So x minus 3 minus 2, and that's if x is greater than 13, or greater than or equal to 3, or less than or equal to 5. So that is that. Yeah, that's all I have for you today. Ooh, you know what? I just realized these should just be greater than, or sorry, yeah, less thans, and these should be less thans. The reason is because we have it covered as or equal to on this side. So just a quick little thing. I don't know why I did that like that, but so that's all I have for y'all today. Hopefully this helped, and of course, have a good day. Bye.